All right, in this video we're going to look at the quiz from lessons 1.1 and 1.5 to 1.8. So just like in other videos, remember that this quiz, your quiz, the order of your questions might be different from the order of the questions that are covered in this video, but they are going to be the same questions. You might just have to skip around to find the answers that you, or the questions that you're looking for. So let's look at this first one. So this first one is a composition of functions, and so this one's asking us to find f following g of 1. So it means I'm going to put 1 into function g first. This is one way we could do it. And take 3 times my input, which is 1 minus 4. When I do that, I get negative 1 as my answer. So then I'm going to put negative 1 into function f. Function f says to take in square input, multiply it times negative 2, and then add 5. So when I square negative 1, that's a positive 1. Negative 2 times 1 is negative 2, and negative 2 plus 5 would just be 3. So that's one way we could go about doing this problem. Now, the other way you could go about doing it is recognizing that I'm putting function g into function f. And so some of you guys might have done that. It's a little bit trickier for this one, so personally I would have just done it the other way. But if you did this, or you put function g into function f, and now what you could do is you could put not negative 1, you could put 1, because that's what we're putting into this composition of functions. If I put 1 in here for x, 3 times 1 is 3, 3 minus 4 is negative 1, negative 1 squared is 1. So all of this would be 1, and negative 2 times 1 would be negative 2, negative 2 plus 5 would be 3. So if you wanted to do it that way, where you use the composition of functions, where you put 1 in for x, you could do it that way as well, and you get the same answer. All right, let's look at this one. So this one, it says give the range for the function below. We might want to sketch a graph. And so this is our exponential function. So if you think about the parent function for this, we would have a horizontal asymptote here going through where y equals 0. We would have this x-intercept where the point is 0, 1. That's the parent function. But remember, this x minus 4 means that everything is going to move to the right 4 units, and the minus 5 means that everything's going to go down 5. So let's say this is at negative 5, so now my asymptote would be down here at negative 5. This point that would have been here at 0, 1 is going to move to the right 4 and down 5. So it would have been here, so if we go to the right 4, 1, 2, 3, 4, it'd be here, but then we're going to go down 5. And so it'd be down here at negative 4 would be where that point would move to. So the graph would look something like that. So we want to find the range, though. So the range for this, the lowest point would be at negative 5 and go up to infinity. So we type this in. We would put parentheses, negative 5, no spaces, and then type in INF for positive infinity. All right, so for this one, we want to find the domain and range for this function, or not the domain and range, just the domain. So when I look at this, if I were to put this segment on the x-axis, this point here would be at negative 4, and this point here would be at negative 2. But negative 4 would be an open circle. So we would say it's going to go from negative 4 to 2. Negative 2. So that gives us this branch. Now some of you guys were asking me, they're like, wait a minute, there's only 2 spots here. But there's supposed to be 3 domains. Well, remember, this graph, when I sink this down to the x-axis, it's going to start at negative 1, and negative 1 would be included, so I'd have a bracket there, negative 1. And yeah, we would have an open circle here at 2, but remember, we have this branch here is going to link together with that one to start at 2, and it would be included, and it would go infinitely to the right. So these, when we push these 2 graphs on the x-axis, it's going to be a solid point at negative 1, and then it's just going to go infinitely to the right. So that's how I would refer to the domain for that graph. All right, so this is one where I'm just going to give you a heads up. If you look at the point value for this one, it's just 1 point. That's because there's really no way, since I'm not checking your work, there's no way for me to give you partial credit for this. So instead of having it worth a ton of points, this one I just have 1 point. You either get it right or get it wrong. Now on the test, you're going to be showing your work. So this one on the test will be worth a lot of points. So it's important for you to recognize this process and how to get it right. So instead of writing f of x, I wrote down y equals. So on the test, you could just scribble out the f of x and just replace that with y. So remember, my first step is to change the y to an x and change the x's to y's. Now what I want to do is I want to get rid of the fraction. So I'm going to multiply both sides by 5y. So on the left side, I'd have 5yx. On the right side, I just have negative 2y plus 3, because these would cancel out. Remember, my goal is to get the y's on one side and the variables on the other side. So the only thing I can do right now is add 2y to both sides. So I'd have 5yx plus 2y equals 3. Again, my goal is to solve for y, so I look over here on the left side and I see that I could factor out a y. So I'd have 5x plus 2 in parentheses after factoring out a y. And now again, my goal is to get the y by itself, so I'm going to divide both sides by 5x plus 2. And technically, if this were a test question, I'd want to replace this y with the inverse of f. So that would be my answer. So on the Schoology quiz here, we would type this in as 3 divided by, and then that entire piece is in the denominator, so I want to put that in parentheses, just like these instructions down here say. So we'd have 5x plus 2 in parentheses there. Now I did go through and check these by every person's, and so if you did make a mistake, like maybe forgetting a parentheses on the end, or if you put a space in there where you weren't supposed to have one, you still went back and I gave you full credit. All right, so for this one, we're trying to find the composition of functions, putting function f inside of function g. So if I think about that, function f is square root of x minus 4. So that's what I'm going to put into function g. And function g says to take my input and square it and add 6. So what's my input? My input is the square root of x minus 4. So this square root and this square undo each other, leaving us with just the x minus 4. Well, so negative 4 plus 6 would just be 2. So it would be x plus 2 would be the composition of those two functions, x plus 2. Again, if you put in spaces, it would have marked it wrong, but I went through and double-checked everybody, so I would have given you full credit for that. If I made a mistake and didn't give you full credit for that, make sure you email me and let me know. But now we got to find the domain. So now you might have thought that, oh, the domain is from negative infinity to infinity because I can put anything in there for x. But I do, if I look back, I do see that we have this square root there. So I need to take that into consideration. So this piece, I need to remember that I can't take the square root of a negative number. So x minus 4, what's under the radical there, needs to be greater than or equal to 0. So if I solve that, x has to be greater than or equal to 4. So that means my domain would go from 4 to infinity. So the way that we would type that in is we'd use bracket. By the way, we don't need to use this union because it's everything from 4 to infinity. So I just say 4 comma INF and then parentheses. All right, so for this one, we want to find the domain. So now in the numerator, I see that we have x minus 4. So since in the numerator we have x minus 4, that means that I have to consider the fact that what's underneath there has to be greater than or equal to 0. So I'm going to say that x minus 4 has to be greater than or equal to 0. When I solve that, I get x is greater than or equal to 4. So I got to remember that. So as far as my number line is concerned, I'd have a closed circle at 4 and everything greater than or equal to that. But in the denominator, we have x minus 8. Well, that can't equal 0. So if I solve that, x can't equal 8. So I would have, actually before I would do that, I should have done all of this first, but I would have an open circle at 8. So in reality, my values for x can be anything bigger than 4, but it can't be 8. So the way that I would type that in is I'd have that first segment where I'd have a bracket at 4 going to 8, and then parentheses at 8, and then I'd have from 8 to infinity. So I'd have 8, comma, and then INF to go from infinity, or from 8 to infinity there. All right, so for this one, we're trying to figure out which one of these graphs best represent this parent function, or this piecewise function rather. So x minus 2 squared, so that's going to be a parabola. That's going to move to the right 2 units. So when I look at these choices, now yours would have been bigger, but when I look at these choices, it's got to be either this first one or this one. Okay, it's going to be one of those two. Let me actually do this so we can see these symbols better. And then I see that it's got to be greater than or equal to 0. So that means it would be a solid point. This one here is an open circle, or an open point, where x is 0. This one's got a closed point for where x is 0. So that tells me it's got to be this first one. Let me just double check though. This is a absolute value function, so it's going to be the shape of a v. That's going to move to the left 3, up 4. Sure enough, we're moving to the left 3, up 4. It's going to go from -5 to -2, but -5 is not included, so we have an open circle where x is -5 and a closed circle where x is -2. By the way, on the test, you're going to have to graph this on your own, so you do want to make sure you know how to graph that without having to have any choices. All right, so we want to give the equation for this absolute value function, speaking of absolute values. So outside the absolute value, I would have a negative, or if you said negative or -1, that's fine. There's no stretches or shrinks, so we just have -1 or just negative. And then inside of the absolute value, I see that this is moving to the right 3 units and up 2 units. So if it's moving to the right 3, remember this is happening horizontally, so it would be the opposite of what we'd expect. So it would be x minus 3, not x plus 3, to go to the right 3 units. And then went up 2 units. So outside of the absolute value, we'd have plus 2. All right, lastly, so for this one, I got to describe what's going on here. So I see that we have a negative outside of the square root, outside of the parent function. So that means it's going to be flipped vertically. Inside, or actually continuing on, this would be the 1/4 is again outside the parent function. So that's going to be shrunk vertically by 1/4 the size. So anything outside the parent function affects the graph vertically. Anything inside the parent function affects the graph horizontally. So speaking of inside the parent function, this x minus 5 means that it's going to go horizontally, and it's going to be the opposite, so it's going to move to the right 5 units. And lastly, then that plus 3 is again happening outside the parent function, so that's going to affect the graph vertically. So it's going to go up 3 units. So hopefully that answers the questions that you had from that quiz. If not, make sure you reach out to me so we can get that figured out.